Welcome guys to a new physics lesson, and today we will learn about forces. What is the meaning of force, and what are the types of forces, and how to apply force with different methods. Force. Guys, I would like you to scan the QR code, watch the video, then return back to me and tell me what is the meaning of force. Force is a pull or push on an object to make a change in the object state. Force is a vector physical quantity, which is defined by magnitude and direction. As we said before, guys, force or any vector quantity can be represented by an arrow. This arrow has length and direction. The direction of the arrow represents the direction of the force, while the length of the arrow represents the magnitude of the force. So if we have two arrows, one of them is A and the other one is B, which one has a greater or represent a greater force? Of course A, because the arrow A is longer than arrow B, which means it has a higher magnitude. So, like any vector quantity, force can be added or subtracted and has a measuring unit of Newton. Types of forces, guys. Force has two types: contact force and non-contact force. Contact force is push or pull on an object with touching it, while non-contact force is push or pull on an object without touching it. Examples for contact force are friction force, tension force, normal force. Examples of non-contact force are gravitational force, electric force, and magnetic force. What is the meaning of net force, guys? Net force is the summation of forces that act on the same object. As we said before, force is a vector physical quantity. So it can be added or subtracted. As we can see, guys, if one person applied a force to an object, this object will start to move. But if two persons of the same force applying a net force on an object, this object will stop moving, like this. If I move this one, it will start to move. But if I return it back and apply two forces, this object will not move, will keep its position and state of motion. If we added a force to the right side, so the object will start to move in the direction of the greater force. So we have two types of forces. One of them when the forces are equal, so the applied force will not make the object move, the net force equals 0. And we have another type of force which is unbalanced force, so the object will start to move in a certain direction of the greater force. Which of these options describes an example of a force? A push applied to a door. If two forces act in opposite direction on an object with equal magnitude, what will happen? The object will remain in its current state of motion. In physics, what does a net force of 0 on an object mean? Net force of 0. The object is moving with constant velocity or remain at rest, which means no force is applied. Types of forces, guys. You can scan this QR code and watch the videos and return back to me. We have different types of forces, like friction force, normal force, gravitational force, tension force, applied force, air resistance. Friction force is the force that opposes the motion or the sliding of two objects over each other. Normal force is the force which is applied against the gravity for an object laid on a surface. Gravitational force is the force of gravity. Tension force is the force applied on a spring, rope, or cable as a pulling this string or rope or cable. Applied force is the force that applied on an object by a person or another object. Air resistance, a type of frictional force that acts against the motion of an object. Also, we have a spring force, magnetic force, nuclear force, electrostatic force, centripetal force, and buoyant force. Which force is transmitted through a rope when it is pulled tight? Tension force. What type of force opposes the motion of objects moving through the air? Air resistance. Which force is responsible for the pull you feel when two magnets attract? Magnetic force. Okay, guys. Now you can scan this QR code, watch the video, and tell me, what is the main difference between Newton's first law and Newton's second law? As we said, guys, before, if we have two forces applied on object, and this object, there are two forces applied on the object, and this object is at rest. So this object, after applying these forces, will keep its state of stationary state. It will not move. Even though, if the object is moving and balanced forces applied, the object will keep moving without changing its speed. Let's return it back again. Here the object is moving with a certain speed. So, by applying a force in opposite direction of the same value, the object will not accelerate, but keep moving with the same velocity. So, the balanced forces keep the state of the object, as it has no effect on the object motion. While unbalanced forces will make the object to accelerate. Notice, guys, the speedometer. You will find that the speedometer arrow will increase regularly as force applied in one direction. So the force applied, or net force, which is unbalanced, will make the object accelerate. Here is the speedometer arrow increase, which means this object speeding up, which means the object accelerate. Newton's first law of motion, called a law of friction, of inertia. A law of inertia. If a group of forces act on an object with net force of 0, which means these forces are balanced, the object's state of motion doesn't change. The moving object keeps moving, and the object at rest remain at rest. What is the inertia, guys? The inertia is the force that resists the sudden change in object motion, like when you're in the bus, and the bus stops suddenly. So your body moves forward. Why do your body move forward? Because the body has an inertia. The body moves in the same direction of original motion and resists the sudden change of the bus. So inertia is the tendency of an object to resist the sudden change in its motion. Newton's second law of motion, called the law of acceleration. When unbalanced forces act on an object, this object will accelerate by a value equal to the net force divided by the object's motion. As we said before, Newton's second law deals with unbalanced forces, which has an effect on the object motion. This effect is acceleration. So the object will accelerate. The acceleration of the object is equal to the force applied, or net force applied, on the object divided by the object mass. As we can see, guys, A is equal to F over M. So also F is equal to M multiplied by A. From here we can find another measuring unit for force, which is kilogram of mass and meter per second square. So the new measuring unit of force is kilogram meter per second square. How to apply Newton's second law graphically? As we said before, Newton's second law of motion is the relation between three physical terms: A, acceleration; F, net force; M, the object mass. If we said, guys, the relation between A and F, is it direct or inverse? Direct means increase together. Inverse means one of them increase and the other one decrease. As you can see, guys, A is equal F over M. To know the relation from the rule, you have to write the rule. Just write the rule: A equal F over M. If the two physical terms similar to each other and there is an equal sign between them, that means they are directly proportional. A is numerator, while F is numerator. So they are similar. And equal sign exists between them, so they are directly proportional. While A is numerator and M is denominator, so they are inversely proportional. So the relation between A and F is direct relation, while the relation between A and M is inverse relation, which is mean. As the force applied on the object increase at constant mass, the acceleration of the object will increase. While as the mass of the object increase at constant F, the acceleration of the object will decrease. What is the Newton's third law, guys? Newton's third law is describing the action and reaction. Action and reaction are pair of forces. Action is the force applied by the first object on the second object, while reaction is the force applied back by the second object on the first object. Action and reaction are two forces opposite to each other with the same value, but they never cancel each other. Why? Because these forces are applied on two different objects. To have a net force, the only condition to have a net force and calculate net force when the forces applied on the same object. If the forces are applied on different objects, even though they are equal in value and opposite in direction, they never cancel each other. They never cancel each other. So you can see the man was jumping from the boat, applying action, and the boat going to move back as a reaction. Which is the following statement best describes Newton's first law of motion? An object in motion will stay in motion, and an object at rest will stay at rest unless acted upon by an unbalanced. What does Newton's second law of motion state? Force is equal to mass times acceleration. According to Newton's third law of motion, if you push on a wall with a force of 20 Newton, the wall pushes back with a force of 20 Newton. An object has a mass of 5 kilograms and an acceleration of 2 meters per second square. According to Newton's second law of motion, what is the net force acting on the object? Here is the mass, 5 kilograms, and the acceleration, which is 2 meters per second square, and Newton's second law states that F equal M multiplied by A. So 5 times 2 will provide 10 Newton or kilogram meter per second squared. So the answer is 10. What is the friction force, guys? Friction force, we said before, is the force that resists the sliding of two objects touching each other. Friction force is the force which is always against the motion. Friction force is important for movement. Without friction force, you are unable to walk and running. Cars unable to move. It also prevents the slipping and falling. It's important for braking and stopping motion. Types of friction, guys. We have two types of friction: static friction and kinetic friction. Static friction is the type of friction for stationary object at rest. It prevents the object from motion, and here is the key word, prevents. While the kinetic friction is the friction force that opposes or slows down the object motion. So the kinetic friction is the type of friction which opposes the object motion. Each one of them has a certain rule. Static friction, Fs, is equal to mu S Fn, while kinetic friction, Fk, is equal to mu K Fn. What is the mu S, mu K, and Fn? Let's say that mu S is the coefficient of static friction, which is the ratio between Fs and Fn, while mu K is the ratio between Fk and Fn. Fn is the normal force. But let me ask you guys, which one has a greater value? The static friction coefficient or kinetic friction coefficient? Of course, the static friction coefficient, as static friction coefficient is depending on the static friction, which is greater than kinetic friction. So what is the meaning of normal force? Normal force, guys, is equal to object weight. How come? Let me ask you a question, guys. If we have a table, and above this table, there's a book. This book has a weight downward. But according to Newton's first law, this book is stationary. So there's another force in opposite direction. And this force cancels the weight of the object. This force is applied by the table itself, upward and vertical on the table surface. So the normal force cancels the weight. So the normal force is equal to negative the weight value. And in physics, any negative value for a vector quantity means direction. Well done. So the normal force is equal to the object weight, while object weight itself is equal to the mass of the object multiplied by the acceleration of gravity. So by the end, F as a magnitude is equal to m multiplied by g. M multiplied by g. So, as we said, friction force has two types. One of them is static friction, and the other one is kinetic friction. The static friction is equal to mu s Fn, while the kinetic friction is equal to mu k Fn. As we said before, mu s is the coefficient of static friction, which is greater than mu k, which is greater than mu. Okay, guys, let's solve this problem. A 10-kilogram box is resting on a horizontal surface. So the mass of the box is 10 kilograms. Is resting on a horizontal surface. The coefficient of static friction, mu s, is 0.4. How much force is required to start moving the box? Let's say that if we find the static friction, which is equal to mu s Fn, this amount of force, which is static friction, is able to stop the object and make it stationary. Any amount of force which is greater than static friction will overcome the static friction and make the object start to move. So let's find the static friction force. Mu s is given, which is 0.4. Fn is equal to m multiplied by g. G is the acceleration of gravity, which is equal to 9.81. Let's use it 10 to make the calculation more easy. So mu s is static friction is equal to mu s, which is 0.4 multiplied by 10, which is the object mass, multiplied by another 10, which is g, acceleration of gravity. So the answer will be 40 Newton. So any force greater than 40 Newton will make the object start to move. Another problem, try to solve it by yourself, guys. A 5 kilogram box is being pushed. Here is the mass, 5 kilogram, being pushed along a horizontal surface at constant speed. So the object is moving by constant speed. This object is moving by constant speed. The coefficient of friction is mu k. Mu k is the kinetic friction coefficient, which means the object is moving. What is the frictional force? So he needs Fk, which is equal to mu k Fn. As we said in the previous example, Fn is equal to m multiplied by g. So Fn will be 5 times 10, 50. Mu k is 0.3. So it will be 50 multiplied by 0.3 will equal 15 Newton. We just use 10 for acceleration of gravity to make the calculation easy. Which of the following is true about static friction? It adjusts in magnitude to prevent relative motion between surfaces. The coefficient of friction, mu k, is lower than the coefficient of static friction. What is the relation between normal force and frictional force? The frictional force is directly proportional to the normal force. As the normal force increases, the weight of the object increases, so the friction force between the object and the surface also increases. Vectors in 2 dimensions, guys. First, let's see vectors or applying vectors in 1 dimension. Let's take vector A, putting it here. The size of A is only 1, the side of 1 square. Putting B with in the same direction of A. So the resultant is a vector which is equal to the summation of both of them. S representing the summation. But if we applied C, and we applied C in opposite direction of the same value, so we will find that the value of A and B decreased. By making the value of C is equal to the sum of A and B, we will find that the summation is equal to 0 by increasing the value of C in opposite direction, so the summation will be in the same direction of C as C is the greater one. Applying forces in 2 dimensions. Let's know that, guys. Physics and math don't know the meaning of force applied in 2 dimensions. They have to find the component of this force for each dimension, x and y. So they have to analyze the resultant force. Let's say that force A is applied between x and y. So the resultant will be ax and ay. Ax is equal to 6 and AY is equal to 8. By increasing the value of A, also X and Y will increase. By decreasing the value of A, they will decrease. The component in X direction is called, which is equal to 8, is called X component. And the vector in Y direction, is called Y component. As the vector A moves to X by decreasing angle theta between A and X, the value of X increases and the value of Y decreases. And if A moves towards Y, as we can see, the value of Y increase and the value of X decrease. So guys, if you would like to analyze the vectors and know the rules, as we said, there is a force called A. This force is a resultant force applied between two dimensions, X, dimension X, and dimension Y. So if you would like to find the component of A in X direction, AX, and the angle theta between AX and AX will be equal to A cosine theta. And if we would like to find the component of A in Y direction, so AY will equal to A sine theta. But if we have the values of AX and AY, and we need to find the component, we need to find the resultant, which is A, from the components AX and AY. So I'm going to apply this rule, which is Pythagoras rule. Pythagoras rule. AX squared plus AY squared equal to A. While if you would like to find theta, so theta will be tan minus 1 AY over AX. What is the component of vector A along the x-axis if A has the magnitude of 10 Newton and the angle is 30 Newton? By multiplying or applying the rule of what is the component of A along x direction. So he is asking about AX. So A is 10 Newton and theta is equal to 30 and AX is required. AX is equal A cosine theta. So it will be 10 cosine 30. So the answer will be 8.66. And as A is Newton, so it will be 8.66 Newton. If a vector A makes an angle theta with positive x axis, what is the component of the vector along the x-axis? AX equal A cosine theta. If a vector A makes an angle theta with positive y-axis, what is the component of the vector along x-axis? Now the angle is not between the resultant force or the force itself and x. The angle between theta, between the resultant and y. Let's make a deal. The one which is beside theta takes cosine, and the one which is away from theta takes sine. In this example, x is away from theta, so it takes sine. So AX in this problem equal A sine theta. While if theta is here beside x, so the AX will be equal A cosine theta. Forces on an inclined plane, guys. What is the meaning of inclined plane? Inclined plane is a force, is a plane that make an angle theta with the horizontal. Here is the angle. And this angle make the object on the surface of the inclined plane slides down. We have a group of forces acting on this object. Let's see it. Here is the inclined plane, guys. And here's the horizontal. And here is theta. The object which exists on the inclined plane has a weight downward. Let's know that the axes and the two dimensions, x and y, are calculated according and found according the inclined plane. So, which is mean, here is x, which is parallel to the inclined plane, and y, which is perpendicular to the inclined plane. Here is x and here is y. Which is mean, the weight of the object now is applied between two dimensions, x and y. Here is x and here is y. So, as we said before, physics unable to deal with forces in, well done, two dimensions. So we have to find the components of weight in x direction and in y direction. Let's call weight Fg, which is force of gravity. And by using mathematics, geometry, we'll find theta is here. This angle is equal to theta. So Fgx is equal to Fg. The angle theta is away from x, so Fg sine theta. While Fgy, of course, is equal to Fg cosine theta. So now, guys, we have two forces. One of them downward, and the other one is to the left, according to the gravity, weight. If the object is stationary, which is doesn't move, so there are two another forces making the net force of this net force applied on the object is zero. One of them is against the object weight applied by the inclined plane and perpendicular to the inclined plane. Who can tell me what is the value of this force? This force is normal force. Well done. This force is normal force. And there's another force which is applied by the inclined plane against the sliding down to make this object stationary. Which is against Fgx in this direction. And this one is the static friction. And this one is the static friction. So we have four forces now. Fgx, Fgy, Fn, and Fs. Fgx is equal to Fs, while Fgy is equal to, well done, who said Fn? Fn. So, in this case, this object, which is laying on the inclined plane, is static and at rest as a result of four forces, two opposite each other. Fgx is opposite to Fs, and Fgy, which is opposite to Fn. Fs and Fgx are equal in magnitude and opposite direction, while Fn and FGY are equal magnitude and opposite direction. Forces on an inclined plane. When dealing with forces acting on an object on an inclined plane, the situation can vary depending on whether the object is stationary or sliding. If the object is stationary, as we said, we have Fs, which is equal to mg sine theta, the component of weight in x direction, and Fn, which is equal to mg cosine theta, normal force, and the component of the weight in y direction. If the object is sliding, by the same way, Fn is equal to weight cosine theta, while in this case, the magnitude of Fgx, which is equal to weight sine theta, is greater than kinetic friction. In this case, we don't have a static friction. The object is sliding down. So we have something called kinetic friction. The summary. Forces on inclined plane for a stationary object, Fs equal Fgx equal mg sine theta, Fn equal Fgy mg cosine theta, Fgx is equal mg sine theta, while Fgy equal mg cosine theta, and Fs is equal to mu s Fn. For a moving object, the net force in the x direction, which present the parallel component, is equal to Fgx minus Fk. The object is moving and sliding down by a net force equals the difference between the component of the weight in x direction minus the friction force or kinetic friction force. What is the component of the gravitational force acting parallel to the surface of the inclined plane? Fgx equal mg sine theta. Well done. An object is placed on an inclined plane and is stationary. The maximum static friction force is equal mu s mg cosine theta. What condition must be true for the object that remains stationary? The friction force is greater than the component of weight in x direction, or equal to it. But to remain stationary, the friction force is greater than the weight. What is the coefficient of static friction between the object and the inclined plane mu s? What is the maximum static friction force that can act on the object? Maximum static friction force is equal to the weight of the object in the component of the weight in. So the answer will be mu s mg sine theta. Rotational motion. What is the meaning of rotational motion, guys? The rotational motion when the object moves in a circular path. So it's going to rotate around a center point, which is the center of the motion. Before studying the circular motion, rotational motion, we have to study the circular motion. Here is an object which is moving in a circular path around a center point. This object is moving stationary under two forces. One of them is the centripetal force, and the other one is the tangential force, which is represented by inertia. Here is inertia, and here is the centripetal force. The two forces are perpendicular to each other, and they must be perpendicular to each other. This rotating object move a distance for each cycle is equal to the distance covered is equal to 2 pi r, which is the circumference, and the velocity is equal to this distance, which is 2 by r, covered in a certain time, which is the periodic time t capital. And the acceleration of the object is equal to v squared over r, which is called tangential acceleration, And the centripetal force F is equal to ma, so will be mv squared over r. So we have 4 rules describing the circular motion. The first one is d equal to by r, representing the distance covered in 1 revolution. v equal to by r over t, representing the circular velocity. And the acceleration, which is called tangential acceleration, v squared over r. And last one, centripetal force, which is m multiplied by a, mv squared over r. For the rotational motion is the object which is moving in a circular path or it rotates around its axis. But the rotational motion is measured in different degrees, in different terms. The circular motion, we can say that a circular motion, so the object is moving in a path, this path formed by the end a circle. But if we make this path straight, we can deal with it as a linear motion. But for a circular motion, the whole object is rotating around its axis. So it has to be defined by another rules. It has a certain displacement, it has a certain velocity, and it has a different and certain acceleration. The angular displacement is the displacement of the object according to the angle covered. So the displacement from this position to this position, from this position to this one, is pi over 2, which is 90 degrees. And from this position to this position, from this one to this one, is 180. And make a complete revolution by 360. This displacement is measured by degree, and the degree is equal a unit of 360. 360 is the total angle of the circle. So the degree is 1 over 360. So the angular displacement is a fraction of 1 revolution, can be measured in degrees or radian. So we can say that a radian is defined as 1 over 2 pi, which is 1 over 360 of a revolution. Then angular velocity. The symbol of angular displacement is the same symbol of angle, which is theta. While the angular velocity is represented by omega. Velocity is equal to the velocity in linear motion is equal to distance over time. So the angular velocity is equal to angular displacement over time. And as the linear motion has a unit of meter over second, here also has a radian, which is the measuring unit of angular displacement over second. Angular acceleration. The angular acceleration is the change of angular velocity over time. So it will be change in omega over time and measured in radian by second squared. The frequency. What is the meaning of frequency, guys, for rotational motion? The frequency is the number of revolutions occurred in 1 second. And we can calculate it according to using the rule of omega over 2 pi. By the way, we are going to study the relation between periodic time and frequency at the wave chapter. Frequency is equal to 1 over periodic time. Applying this rule, you will find that in omega over 2 pi is equal to 1 over t. So, how to relate linear motion to the angular motion. Linear motion has a symbol of x and measuring unit of m, the displacement, while the angular has theta and measured in radian. Velocity has a symbol of v and measuring unit of meter per second. The angular omega and radian per second. The acceleration in linear motion has a symbol of a and measuring unit of meter per second square, while the angular has a symbol of alpha and a measuring unit of radian per second square. The relation between, guys, linear motion and angular motion is linear is equal to r, which represents the radius of the rotational motion, multiplied by angular. So, displacement is equal to r multiplied by angular displacement. Velocity is equal to radius multiplied by angular velocity. Acceleration, radius multiplied by angular acceleration. The angular displacement in rotational motion is defined as the distance traveled along the circular path. What is the relationship between linear velocity v and angular velocity omega for an object moving in a circle of radius r? E equal r omega. What is the torque, guys? The torque is a force that applied on an object to make it rotate. Force, as we said, torque, force, so we can consider torque as a force in rotational motion. So the torque is the change in angular velocity. Depends on the magnitude of the force, the distance from the axis to the point where the force is exerted. I'm going to apply a force, guys, to make this object rotate. So, by applying this force, I will make the object rotate. Then, can you notice the speed of rotation? I will apply the same value of force, which represent torque in rotational motion, at a point near to the center. Now it's the same value. Oh, the speed of rotation decreased. If we applied the same, again, here is the value, very fast, going to rotate very fast, applying the same value near to the center, the speed of rotation is lower than the previous figure. So we can say that the torque is the force applied to make the object rotate and depends on the distance between the center of motion, the center of rotation, and the force applied. So, if you would like to open this door, we have three different positions to apply force. One of them just beside this joint, rotational point, and another one at the center of the door, and the last one at the edge of the door. Which one provides a greater rotation and makes the door rotate and be opened easily? I think the one is at the edge. So, if I would like to make an object rotate, here is the object and here is the arm of rotation. So you are going to apply a force this force perpendicular to the arm of rotation, and as the arm of rotation length increase, that means more torque is applied. More torque is applied. But if we apply the force with an angle which is not perpendicular to the arm of rotation, here is the arm, and I applied the force like this. The effective force is the perpendicular force. As we said before, this force can be considered as a force applied in two dimensions. And as if physics doesn't deal with force or any vector in two dimensions, so I have to find the force applied perpendicular to, which is F dash. Here is theta, so F dash is equal to F away from theta, so sine theta. Here's the rule, will be torque toi equal to F time multiplied by R, which represents R. But here, torque is equal to F R sine theta. F R sine theta. So the torque is equal to F R sine theta. If theta is equal to 90, so sine 90 will be 1, and torque will be F R only. Moving to another point, guys, called moment of inertia. Moment of inertia is the resistance of rotation, which is exactly similar to inertia. But here, for rotation, as R differ, which is the distance from the rotation point, also the moment of inertia differ. And as R increase, the moment of inertia increase are directly proportional with the square value of distance, as I directly proportional to R square from the rule. So the resistance of rotation is called the moment of inertia, which is represented by the symbol I, and has units of mass times the square of the distance. For a point object located at a distance r from the axis of rotation, the moment of inertia is given by the following equation: I equal mr square. Let's say, guys, this rule differ according to the shape of the object. By the end, if he is asking during the exam to find any moment of inertia for a different shape which is not equal to I mr square, he must provide the rule inside the problem. As we can see, different objects have different moment of inertia. The semicircular ring has a radius r, the force perpendicular to the center, so the rotation perpendicular to the center is going to rotate around its axis, mr square. If it's going to rotate around an axis which is parallel to the surface of the semicircular, so it will change into mr square over r. Anyhow, you have to notice that always I is equal to a number, half, 1 over 12, 1 over 4, but by the end, this number is multiplied by mr square. So the moment of inertia always has the same measuring unit, which is mass measured in kilogram multiplied by meter squared. Multiplied by meter squared. As we said before, guys, if I'm talking about rotational motion and the angular acceleration, let's first revise the linear acceleration, which is equal F over m. F is the force or net force applied on the object, while m is the mass. The angular acceleration alpha is equal to the torque, net torque, divided by I. From this rule, we can notice that torque is equivalent to F, while I is equivalent to mass. Torque is equivalent to the force applied in the linear motion to make the object accelerate, and I is parallel, not equal, parallel or similar to the mass of the object. So, by the end, Newton's second law for rotational motion, the angular acceleration is directly proportional to the net torque and inversely proportional to the moment of inertia, similar to A equal F over M in linear motion. The net torque on an object is zero. Which of the following must also equal zero? Angular acceleration. Which of the following units is commonly used to measure moment of inertia? Kilogram meter squared. The moment of inertia of an object depends on its mass and shape and mass distribution. Newton's second law of rotational motion can be expressed as I equal mr squared. Torque is the product of force and distance from the pivot point or rotational point. Is the same. Moving to another part, which is called Kepler's law. Kepler's law are laws which control the motion of planets in the space around the sun. Watch the video, scan the QR code, watch the video, and let's play with fit simulation. The first law of Kepler. The path of any planet around the sun is oval path or ellipse path, which is mean is has two radius from the sun. One of them is long and the other one is short. By making the planet rotate around the sun, the length of the axis differ. The distance between the sun and the planet differs, which make the planet change its velocity. As the radius or the axis length increase, the planet moves slower. To avoid, here is the value, to avoid escaping from the orbit. As it moves close to the sun, its speed increases to avoid the movement towards the sun. So the first law of Kepler states that the orbital of the planet, any planet around the sun, not a circular path, it's an ellipse path, which has two axes. One of them is long and the other one short. Moving to Kepler's second law, which the line which joins the planet and the sun cover equal areas at equal intervals of time. Equal areas at equal intervals of time? Yes, because the speed of rotation differ. So if the line which join Earth or a planet and sun decrease, the speed increase, so it covers a longer circumference. While if the line joining the planet and the sun increase, the speed of the planet decrease. By the end, the line joining the planet and the sun covers equal areas at equal intervals of time. As you can see, guys, the graph at the left side shows the areas, and in the same time, the areas are equal and the time is equal. Moving to Kepler's third law of motion. Kepler's third law of motion is the relation between periodic time and the radius of the motion. The square of the time is directly related to the radius cubed, which are equal to each other. So the ratio between them is equal to 1. Let's see that. I'm going to choose T and A. It's not equal to 1. I'm going to choose T cubed and A squared. It's also not equal to 1. But if we choose the time squared and radius cubed, we'll find that the ratio is equal to 1. So T squared over A cubed, T squared is the periodic time. A cubed, we can replace A by R as the radius of motion, cubed, have the same value. So for different planets, Kepler's third law can be changed and defined as the following. Kepler's third law can be defined as T1 over T2 squared is equal to R1 over R2 cubed. 1 and 2 represents the first and second planet. Represent the first and second planets. Kepler's first law states that the bases of the planets are ellipses with the sun at the focus. Kepler's second law states that an imaginary line from the sun to a planet sweeps out equal areas in equal time intervals. The third law of Kepler's states that the square of the orbital period of a planet is proportional to the cube of the orbital's semi-major axis. Semi-major axis, which means the axis. Newton's law of gravitational force, or universal gravitation. Any object has a mass, has its own gravitational force. Has its own gravitational force. So me and you, every one of us, each object exists at this universe has its own mass, has its own gravitational force, or gravity. Let's say gravity, not gravitational force. Let's say gravity. The gravity is the attraction force applied by any object that has a mass, while gravitational force is the attraction force between two objects have masses. So the gravity belongs to one object. Gravitational force belongs to two objects. We couldn't and can't notice our gravity as we have very small mass. As the object mass increase, its gravity increase. So the force of gravitation between two objects depends on the masses of the two objects. So we can say that Fg is equal to Gm1 m2 over r squared. m1 is the mass of the first object, while m2 is the mass of the second object, and r is the distance between their centers, while g is the gravitational constant, which is equal to 6.673 times 10 of power negative 11 Newton meter squared per kilogram squared. So Kepler's first law states that the orbit of a planet around the sun is elliptical orbit. Kepler's second law, or the law of equal areas, states that a line joining a planet and sun sweeps out equal areas in equal times. Kepler's third law relates the orbital period of a planet to its distance from the sun. Orbits and planets and satellites. How do scientists launch satellites around the Earth? The process of launching satellites around the Earth depending on the free fall. and the gravitational force between the planet and the satellite. Let's say that here is the Earth. Scientists launch the satellite to the space to reach a certain point. At this certain point, this satellite is going to fall down freely, moving down. The only force acting on this satellite is the centripetal force toward the center. And there is another one which is perpendicular to it, which is the inertia of falling. As the two forces are perpendicular to each other and equal in magnitude, the satellite will keep rotating around the Earth in a circular path. To find the values of v or time or acceleration, let's say that the rotation of satellite depending on the mass of the Earth, which is the object at the center and controls the motion. By similarity, the rotation of the planet around the sun depends on the mass of the sun itself, as is the object at the center and controlling the motion. So, if I'm talking about satellite, the velocity of the satellite is equal to the square root of gme over r. G is the gravitational constant. Me is the mass of the Earth, the object at the center. R is the distance between the centers of the satellite and the center of Earth, which is equal to, R is equal to the radius of Earth plus the height of satellite. The periodic time is equal to 2 pi the square root of r squared gme. And the free fall acceleration is equal to g r e over r. While r e is the radius of Earth, and r is the radius of the satellite motion. The radius of the satellite motion, which is calculated from the center of the Earth. As we said, r is equal to r capital plus h. What term is used to describe the time it takes for a planet or satellite to complete one full orbit? Periodic time. Which of the following best describes geostationary satellite? Geostationary, geography, stationary, constant. It's a satellite which is rotating by the same speed rotation of the Earth. So it seems to be stationary from the Earth's surface. So it's a satellite that stays in the same position relative to the Earth's surface. The speed of planet in orbit is primarily determined by the distance of the closest neighboring planet. Now we're done with the third session, guys. Prepare your questions for the live session, and good luck, inshallah.